Okay, this is for DC circuit 0.07, and we are finding the resistance across this circuit, and so these are in a series, and so the equivalent resistance is going to be, well, we can actually, so we can, one loop is through these resistors, so that's 250, whoops, ohms plus 100 ohms plus 50 ohms plus 200 ohms. That's 450 by 50, 600 ohms. And so based on that loop, we can say that the battery divided by Req is going to be 150 volts divided by 600 ohms, which is 15 divided by 60. That's 1/4. That's what I thought it was. 0.250 ohms, or amps, sorry. So, hold on. So I'm gonna look at what does it say? Okay, so it says determine the current through each resistor and the magnitude of the charge on each capacitor. Am I looking at the right one? Oh yeah, 150 volts, sorry. I didn't put that. So it's saying determine the current through each resistor and the magnitude of the charge on each capacitor plate after the circuit has been connected for a few minutes. So this is okay, so we're looking, so the current is 1/4 amps, and then it wants, so that's for like the outer loop, and then based on knowing capacitance, or what capacitors do, they store charge, and so it's saying that after quite a bit of time, so the battery is going through here, as well as the capacitor, and it's storing up that current there, so that at this resistor of 75 ohms, eventually, due to time, there's going to be a blockage. This is kind of like a speed bump, and so it's going to create where there's no current flowing through, because it just it's collecting it, it's storing it to its max, and so once it gets to its max capacity, it's not going to be giving any to this resistor here, and so we can say that it's only the outer which are experiencing current after quite a bit of time, and then and that's 0.250 for this. So let's say R1, R2, R3, this will be R4, and this will be R5. And so R4 is the I4 is equal to 0. And then the rest, R1, R2, R3, and R5 are experiencing oh, that's a funny way to put it. The current is 1/4, so 0.25 amps. And so we've answered that part of the question. And so then it said hang on, what did it say? It said so determine the current through each resistor and the magnitude of the charge on either capacitor plate after the circuit in this figure has been connected for quite a bit of time. Okay, so now we need to find Q, knowing that C times V equals Q. And so we have a capacitor here, so 40 times 10 to the negative 6 farads. And then amps, 0.250 amps times 100 ohms plus 50 ohms, because that's V. I times R. And that's volts. So I plugged it in. And then, well, I'm going to have to do that on my calculator. So 40 times 10 to the negative 6 times 0.25 times 150. And we get Q is equal to 1.5 times 10 to the negative 3 coulombs. So the outer resistors are experiencing a current of 0.250 amps. I don't have to say 0. I just kind of did because there's three. There's three figures, but really it's just going to be 2 sig figs. So 0.25 amps. And then, so that's for this guy, this guy, this guy, and this guy. And then the current, and so then this current here in the middle is getting 0. And then the charge here is going to be C times V, and we know that V is equal to I times R. So we can plug all of the known values in, and we get 1.5 times 10 to the negative 3, which you could even say micro coulombs if you wanted. 1.5 microcoulombs of charge. Okay.